Okay, so just going to describe at a high level some of the key features just to kind of put it in the right mindset of what Hortonworks Dataflow powered by Apache NiFi will provide out of the box. And then we'll talk through a little bit of the architecture and do, look through the actual app through slides. So the first thing to talk about is guaranteed delivery. As you increase the volume of data and as you deal with the fact that there are power failures and system failures and network issues and so on, it's really important that you have a robust guaranteed delivery story. That means providing transactional communication to wherever data is coming from, as well as within the data flow system itself, in addition to where it's delivered. And it's really important to keep in mind here, we're not talking about a transaction between the producer and the consumer. We're talking about a transaction between NiFi and the system that it's getting data from, as well as NiFi and the systems it's delivering data to. Most data flows really aren't linear, right? They form these big graphs where data comes in but then is delivered to multiple systems in parallel. And so you have to have robust kind of transactional guaranteed delivery stories, and NiFi certainly does that. I'll describe that a little bit as we look at the architecture here in just a minute. The next thing then is data buffering. And fundamentally the thing to keep in mind whenever you're in the data flow business, whenever you're in the business of connecting systems, no matter what, there's always some system that is down or degraded. And that's just a reality. And so you have to inherently support buffering. To be able to tolerate those systems that may not be online at any given moment in time, may not be able to keep up with the rate of data flow. And so what this also means then is you have to have some important kind of first-class features. One of those then is back pressure. It's not enough to just simply buffer indefinitely and then the data flow system itself becomes at risk. So you have to have some way of effectively throttling all the way back to the point where you may in fact slow down the consumption of data. Now you may say, in the case of my organization, I can't do that, right? The producer's always sending data. I have to always be listening. And that's fine as well, right? You have to make a choice between whether you have back pressure or some sort of pressure release mechanism. And so NiFi supports both models because these are just kind of realities that exist in data flow. The next thing then is if you have this data buffering, very often what you want to be able to do is prioritize data. It's commonly talked about today as kind of like natural ordering or insertion order, and that makes sense for a subset of use cases. But in the broad sort of enterprise sense, as you're dealing with constrained bandwidth or constrained resources, you have to make prioritization decisions. And so the queuing mechanism that NiFi supports allows you to prioritize data dynamically. As Tim mentioned, thinking about the jagged edge in particular, you can imagine that when your access to data exceeds the bandwidth you have to send it back, you fundamentally have a prioritization decision to make. And that's really what drove this kind of design long ago. The next thing to talk about then is flow-specific quality of service. And what we mean here is it's not enough to just tune the whole system to be low latency oriented or tune the whole system to be high throughput oriented. I mean, these are somewhat at odds ideas. And there's trade-offs being made, and we want to enable people to make those trade-offs at very specific points in the flow and specific to what that particular data flow needs or that particular consumer might need. And so we allow you to control that at a really fine-grained level. But at the same time, we also allow you to control loss tolerance. You may have situations where you have a developmental flow or a flow that if it's not delivered within some time, right? Tim talked about perishable insights, for example. If you have data which needs to be consumed, let's say, within seconds to be of value, well, once it's minutes old, then you can terminate it. And so we enable you to choose the points in the flow that if you do want to let data age off, then it will do that for you. You can think of that as being a form of that pressure release we described a moment ago. We already talked a little bit about data provenance on the previous slide, and I'll show you what that looks like in the application just to make that more concrete. It's a bit of a unfamiliar term for a lot of folks. It's not a new concept, but it is a very important idea to discuss, so I'll describe that further as we go ahead. The other thing to keep in mind is we're building this rolling log of really detailed history of what happened, both to the content of data as well as the context or what we've learned about it. And we want to keep that as long as we possibly can. It's not just once data enters the flow, I keep track of it until it's out and then I get rid of it. I want to keep that as long as I can. Real-time is important. Being able to interact with the flow is important. But it's equally important to be able to go back in time and sort of step through and understand what happened. And the architecture that we have, the provenance data that we have, allows you to do that in a really powerful way. The other thing then is visual command and control. Think of this as part of that management story I was describing. What we want to enable people to do is to have real-time or interactive command and control with the data flow. This is really important because largely what people see today are design and deploy type systems where you may be able to build the flow that you need visually, but you're building it kind of all at once and then you deploy it out. The problem with a model like that is the feedback cycle is too slow and the cause and effect is kind of blurred. You can think of NiFi as providing this really immediate feedback to every change that you made. And that's important because it helps you understand whether what you did had a good outcome or a bad outcome. And if it's not what you were looking for, then you can immediately correct it and kind of keep iterating. Now, the key thing to keep in mind there is when we say, visual command and control, people immediately assume kind of the human use case, right? The human actor making changes to the system. But again, if we think back to this bidirectional data flow story we're talking about here, the interactive command and control doesn't just enable people to make changes, it enables systems to make changes. Autonomous feedback is kind of the idea to think about. What we want to be able to do is have analytic results immediately feed back to changing the behavior of how the data flow works. That could be changing prioritization decisions. It could be electing for recovery cases to kick off. It could mean adding new data flows or removing existing ones. Whatever the case may be, everything that a person can do through the data flow, we want systems to be able to do as well. That has a lot of implications on how to design the system. The other thing then are these flow templates, which is to say that you can build data flows, establish and test them and decide that they're sort of gold standard, good to go. And now you can save that as a pre-configured component, if you will, an already connected set of processors and relationships that allow data to flow a certain sort of predetermined way. And now you can share that with other organizations, other teams, configuration, manage that, whatever the case may be. It enables sharing and reuse, but on a higher level. The next thing is that we have a pluggable authorization model today that allows you to take and use something as simple as a local file as an authority mechanism, but also to call out to an external service. Think of something like Active Directory or some third-party authorization service that you may already have. Every organization has some form of one, and so we just know from the outset that this is something that has to be pluggable. Similarly, we already support multi-role security, things like users who can only read the flow or see it but not manipulate it. And we'll go into this a bit more here as we dive into the security story in a few slides from now. Another key point to bring up is that it's designed for extension. Anyone who's dealt with the data flow problem, if you've ever made a script, if you've ever run kind of traditional integration tools, or if you've ever had to connect systems using whatever mechanism the case may be, you know that it's never done. This is an inherently last mile challenge. There's always some new protocol, always some new format, some new schema, something that requires you to go beyond all the tools that are already sitting in the toolbox. And we understand that from the outset. NiFi is designed to be easily extended in a way that allows you to build components that still show up looking consistent and cohesive in the UI, and that allow you to have a lot of built-in fault tolerance, error handling, sort of consistent behavior. The final point to make, while Tim talked about it earlier, is we want to be able to support those really small environments, but sometimes you are running in a large data center. And so, we have a scale-out story through this clustering mechanism. We're not talking about hundreds or thousands of nodes here. We're talking about a set of nodes all working cooperatively to feed data into the processing systems, be it Storm, Spark, or others, where those would have potentially a much larger footprint.